Basically, what happens now here in sliding friction, the objects, the surface of the objects are made up of, it looks like hills and troughs, right? So they basically get interlocked into each other. I know.
Yes.
And then we had some of the effects as well. We discussed in this one, flowing effect now. Okay.
Yes,
What is it, Arham, flowing effect? Flowing effect, we discussed about it. Look here. Usually there's a heavy object put over a soft object here. Yes. Okay. And here basically this soft
they can
object.
change their shape easily.
Exactly. It is basically sinking. They are basically sinking into each other. It looks like as if this heavy object has sinked into this carpet here. So that's where you will see a wave-like structures form here, valley-like structure forms here.
Yes, sir.
Right. Adhesive forces and cohesive forces. What are they? And where give the examples as well. Where can you see adhesive forces and cohesive forces?
Second,
Yeah, sure.
the adhesive forces is the force in which two forces are in contact and they start to form bonds and begin to stick it to each other.
Exactly. Then what about cohesive force?
The cohesive force is the attraction forces between the water molecules.
Basically molecules of the fluid, not especially water molecules, right? That basically gives the water molecules a rectangular shape.
No, it's a circle-like shape.
Circular-like shape, round shape basically, right?
Yes,
okay. We also talked about how do we calculate frictional force using a spring balance.
Yes.
Okay. Right. Then the rolling friction, right? So it is slightly less than the sliding friction as it reduces the friction. Here you can see the applications of the rolling friction as well, right? Okay. The benefits here is that it is simply reducing the friction since lesser surface areas in contact here.
Yes, sir.
It reduces the area of contact between the surfaces. Then fluid frictions, right? So fluid frictions, for example, when an aeroplane is moving, when a fish is moving in the water, right? So friction that is generated there. So fluid friction, it is not necessarily to be a watery medium or liquid medium. It can be air, can be water as well, right? Now the question here is that how do the fishes reduces this friction? What are the adaptations?
Due to the streamlined body.
Exactly. So see their shape here. See their shape here. The shape of this plain shape of the bird. Okay. In fact, the bones of the bird you see, they are hollow.
Yeah, very light.
Very light. And the wings give them flight. Okay. Okay, so here, these are the objects which are made to move in the fluid or organisms. They have got a streamlined shape to reduce the friction. In fact, the shape of the cars, racing cars especially, they are also a streamlined shape, right?
The aerodynamic.
Aerodynamic shape, right? Okay, so one more thing, fluid friction will depend on certain factors. For example, the speed of the object relative to the fluid, right?
Yes.
The shape of the object, the size of the object, and nature of the fluid. So for example, different fluids have got different viscosity.
Yes, sir.
Right. For example, if you have got, let's take an example here, honey, water, petrol, or grease. These are all liquids, these are all fluids, but viscosity in them is different. If you were to pour all these substances at the same time on ground, they will spread on the ground at, they will acquire different areas, right? Different
honey and
area.
petrol are more viscous.
Yeah. What is the most viscous liquid here? Right.
Yes.
So that will also determine the fluid friction. So if an object were to move under a grease, or under a honey, it will be experiencing more fluid friction, right? If the object, the front shape is blunt, right? Object is like this, it will be experiencing more resistance, whether it be in air or whether it be in water. So that will basically lead to more resistance, hence more heat generation.
Yes, sir.
Okay, the nature of the fluid that we talked about, if it's viscous. Okay, ways to reduce friction, we discuss it here, right? Okay, apart from it, we might also make some changes in the fluid also. For example, we might do changes in the water body only, not in the air, right? So if there's pollution in the water, right, if the water has become more dense due to addition of impurities in it, so that can be cured. So doing that will also, that will basically change the nature of the fluid. Okay, hence the friction can be reduced in that manner, right? Okay.
Yes, sir.
Now, next thing is friction. Friction has been called a necessary evil. Why is it so?
So since there are advantages and disadvantages. Yeah.
Very good. It has got some advantages while it has got some disadvantage also. For example, on the soles of our shoes, the grooves are present there, and grooves soles provides increased friction to the ground, right? So that provides us with a greater grip in while we are walking, right? And because earth has also friction, we can walk easily, right?
Yes.
Okay.
Yes,
Now, if you were to move on a wet, muddy route, or a damp marble floor, that will be a challenging task now, because their surfaces provides relatively lesser friction
Less
to the
friction.
person's
Yeah.
feet. No. So there are certain advantages of friction which we are seeing here. Okay. For example, friction also helps in the generation of heat. So someone is feeling cold, he can just rub the hands. Okay, that will give a slight amount of comfort. Okay. In forest, when the matchsticks and technologies of burning the fire were not developed, people basically used to rub the stones, rub the woods across each other. That lead to generation of heat. Friction also helps in stopping bicycles or different vehicles when you apply brake.
Yeah.
Nails can be stuck into the wall, fixed into the wall, because there is friction there as well, right? Okay. In fact, most of the activities which we are able to perform, which we are able to do, it is because of friction. In fact, why we are able to sit on our chair, there also friction is taking place. Otherwise, you would have just slide down, right? So if you were to pour some amount of oil on the chair and then try to sit on it, then that will be a bit of mess, right?
Yes. Yeah.
The motion of pistons, right? The motion of pistons, ignition of matchsticks, these are all examples. In fact, the list goes on and on, right? Then some of the disadvantages also, like in some cases, production of heat due to friction is good, but in some cases it is bad. For example, forest fires, right?
Yes.
So they are bad, right?
Yes, sir.
Okay. Then friction also resists motion now, right? So in case like you have in case, like, let's say that a door is jammed because of too much friction, so the motion of the door is being restricted due to the increased friction, right?
Yes, sir.
Okay.
Then we add oil to solve it.
Exactly. For example, the pistons present in the engines of the car, right? Pistons, it is found in the engines of the car. So there are also, if the lubricant has dried, that will lead to generation of friction, right? So there you will see more and more fuel will be consumed. Consumption of more fuel will be seen in the vehicles then, right? Then also you will see friction also leads to generation of sound as well. So it might lead to sound pollution as well. No. Okay. Now, what are the ways to reduce this friction? One of the ways to use lubricants, right?
Yeah.
Lubricants are basically like oils or grease. Okay, name one example of a dry lubricant.
Graphite powder.
Graphite powder. Very good.
Yes,
Right.
sir.
Okay, then in the vehicles, instead of using rectangulars or different tires, we basically use circular shape, right?
Hmm.
The streamlined body
Yes.
of an object can also help to reduce the friction. Use of ball bearings, sprinkling powder on a dholak can also reduce friction, right? Polishing
Yes, sir.
surface to make them smooth, okay, so that they will slide basically on one another. That also reduces the friction. Okay,
Yes,
then
sir.
you have got certain ways also to increase friction. How can we increase friction? Arhan, you give
So
me
by
some points. Yeah.
making the area rough.
Making area rougher, right? So that will basically do what?
So
Increase.
it will increase the friction.
Right. So basically, you will see that the surface was like this. Now, if the surface is like this, there will be interlocking effect. No,
Yes, sir. Yes.
interlocking effect will increase. Right. And what can be done? Suppose if you were to increase the mass of the object that is moving. For example, you are sliding a small piece of stone on earth. Now you have got a bigger piece of stone, or you have added so many stones on it, tied so many stones to it, right? So the mass has increased here. So due to increase in mass, the force that is that is here between this rock and the earth,
Yes, sir.
the force with which they are compressing each other, that has increased now. So that
Yes,
will also
sir.
lead to generation of more
Yes,
friction.
sir.
So increasing the mass. What else? Arham, what else? What else can be done?
By increasing the area of contact.
Exactly. Increase in area of contact. Good. Then
So not using lubricants.
when not using the
Lubricants.
lubricants. Okay. So these are the things which we can do. Right. Okay. So basically in the chapter, we have studied about friction, what are the cause behind the friction, right? And we see that friction is essentially the resistance that any object encounters when it is traveling across a surface or medium, right?
Yes.
And that
So there's one
depend.
more point.
Yeah.
So
Which
reducing the force
yeah,
applied.
very good, very good. Reducing the applied force, right? So suppose there's an object lying over here, you are pushing it with 10 Newton force. So this object will be resisted by a force greater than this, right? I mean, if you were to reduce the force with which you are pushing it, then amount of friction will also be reduced, right? So in the chapter, basically, we have discussed several things. Okay, we have talked about different types of friction, like static friction, sliding friction, rolling friction, then fluid friction. Okay.
Yes.
Okay. You guys tell me, what was the SI unit in which frictional force is measured? Arhan, was it not equal to Newton? You guys remember that spring which we were using, this weight spring? What was the
Yes.
unit of the reading in this? Is it not 5 Newton here?
Newton. Yes, sir.
Right. So it is a Newton, guys. Right. Okay.
Yeah.
Okay. So right now in class, basically this is all you guys have to study about friction. But still, I would like you guys to solve some numerical problems. Are you guys
Yes.
okay with it?
Yeah.
Yes,
Yeah.
sir.
Okay. Okay, let me clean this page over here. Let's see if we have got enough space. Okay. So normally we see that at any given point of time, an object will occur 4 different types of forces if it is being moved, push or pulled. So it will have a force called applied force on it,
Yes.
right? Then
Yes, sir.
it must be having some weight also. So that will apply a
Yes, sir.
downward force right now. Then opposite to the downward force, there's one more force acting here that we call as normal force. Okay, just get to know this force here, normal force. Okay, no need to go behind the science, no need to go behind the science of it right now. Just know this, that this is a reactionary force. Okay, we take it as a convention. Okay, now this body must be applying some resistance to the force applied here that we know as frictional, right now. Okay, now
Yes, sir.
talking about the frictional formula. What is the frictional formula here, right? So the friction formula here now, friction formula that we're talking about. Okay, now frictional formula is typically given as this. Friction formula is given as like this here. Friction equals to F1 here. Now, what are these values here?
Sir, N equals to normal force, F is equal to friction, and W equals to weight.
No, there's no W here.
That's N.
There's no W here. This is basically a coefficient sign here. Getting it here? Okay. So here the numerics are the magnitude of the force, that is F here. Let's say it to be F. Getting it? It is the magnitude
Yes,
of the friction here. Okay. Then friction has got some coefficient also. Where's the page here? This is called as coefficient of friction. Getting it? And the magnitude of the normal force, as Arhan was saying here, this F1 here. Magnitude of normal force. Yeah. Magnitude of normal force, coefficient of friction, and this is basically the magnitude of the friction.
Yes.
So here we have got 3 components in finding formula of a friction, right? Okay. Now this normal force here, a few more things here to note before we conclude the discussion. The normal force is equivalent to the weight of the given body, right? So therefore, in the calculation, you will take this F1 equals to the weight of the given body. I know the normal force is I'm writing it in short, equivalent to weight of body, right? So F1 here is equal to weight. And how do we calculate weight, guys? Any idea? Mass into gravity.
Yes, sir.
That is how we calculate weight. Hence, that is the reason why weight varies. For example, here you are standing on Earth, the gravity is different. If you were to stand on Moon, the gravity will be different. That's why now weight varies from planet to planet, from different terrestrial body to different terrestrial body, right? Okay.
Yeah.
So F1, it can be further written as mg, right? Okay. So the mass and gravity is given here. Okay. So let's look at some of the questions here. If you guys like, you guys can take the screenshot here.
Yes. I've taken.
I've taken, sir.
Okay, good. So let's erase this one here. I'm giving you some numerical problems, right? Okay, let's say a child is pulling a box of mass. Let's say it to be 10 kg here. And the child is basically pulling it. Okay.
Yes.
Now you need to find the standard force acting and also find the frictional force here in this case, while the coefficient of force is given. Coefficient is given 0.3 here. Right. So let me solve this question for you. When we will move on to the next question that you guys will be required to solve. Okay. So as per the question, what are the given things here?
The coefficient,
The mass, the weight.
Mass, not weight. Mass is given here, no? Okay. Now, what was the question which was, what do we needed to find? We needed to find the standard force acting on it also. Okay.
Yes.
I mean, basically the
Yes,
normal force, this Fn here.
So
Okay.
you also said we need to find frictional force.
Exactly. That also needs to be found here. Okay. So Fn is equal to what? That is the question here. Let me write it over here. Normal force, no? Right. So we know F1 equals to M into G. Okay.
Yes, sir.
So on the values given here, M given here, G we know.
Yes, sir.
Right?
Yes.
G is 9.8
Yes,
meter
sir.
per second square. Gravity of Earth, that is it now? 9.8 meter per second square. Or we can simply call it to be what?
9.8
in terms of Newton also. Getting it? It will be
Yes.
simply 98 Newton.
Yes.
Right. Okay. So the normal force that we can calculate easy. Now we know the formula to calculate the frictional force. Can you guys recall it? We just discussed it moments ago.
Yes, sir. The coefficient multiplied by mass.
Coefficient multiplied by normal force.
Fn. Yes, sir.
Right. So frictional force equals to coefficient multiplied Fn, right? As the values are given here. Coefficient is given. Normal force we can calculate here. So that is going to be how much? 0.3 multiplied. Sorry, 10 multiplied 9.8.
9.8. Yes.
Okay. Okay, here it's going to be 9.8 Newton. Sorry. So here we get 98 Newton, right?
Newton.
That is the
Yes,
normal force acting on the object here. Now let's calculate the frictional force. That will be 0.3 multiplied 98 Newton. Quickly calculate the magnitude here. What is the value we're getting? 0.3 multiplied 98. So it should be somewhere on 28 or 29.
29.4.
29.4. Excellent. 29.4 Newton is the frictional force acting on this body. Getting it? So in which direction is it acting? In this? In which direction?
Left.
In this direction. Right? Because it is being pulled on this side, left side. That is 29.4 Newton. And the magnitude here is 98 Newton, right? Okay, that was quite easy to calculate, right? Whatever the mass is given, simply multiply it with 9.8. Okay, now let's take one more question. If you guys like, you can take the screenshot of this one.
Okay, sir. Sir, done.
Yep.
Yeah, done.
Okay. Now, next question I'm giving you that Nancy whose mass is 40 kg is slipping to the frost. Okay, Nancy, let me add the question, of mass 40 kg is slipping to the
So we have to write?
frost. No, no need to write. You can see the question from here. Okay. Now, if the coefficient is given 0.45 here. Okay. Find the frictional force acting between her and frost layer. Frost, you know, that is
Okay, sir.
that is basically ice. Find frictional force between her and layer of frost. So this is Nancy here whose mass is given here. She is basically sliding on the ice now. Okay. We need to calculate the frictional force happening here, taking place here. Okay. Okay, that is easy.
Yes, sir.
Yeah, calculate this one.
Sir, what is written after frictional force? I can't read
between, in short, I have written it as between her and layer of frost.
Oh, okay, sir.
Okay. Arham, I received your assignment, your maths assignment, algebraic expression. Okay, in that you have done a slight mistake here. Like as per the board mass rule, now, like there was a question, if I remember. I will be showing you the screenshot of the question. The question was like this: 3/2 multiplied minus 3 plus 5. It was something like this. Plus 3. It was plus 3 over here. So what you have done here now, you have just did this. You have added minus 3 and plus 3. While this 3/2 was in multiplication with minus 3. So as per the board mass rule, you have to first do the multiplication part. Right. So rather than adding them, it should be minus sign upon 2 plus 3 then.
Yeah. Sir, I
Right.
found the answer.
Okay. Yeah. Let Arham solve it. Then we will be discussing it. Okay.
Sir, shall I send the answer in the chat box?
Yeah. You can surely send it in the chat box.
Okay, sir.
Okay. Send it on the ID, not my full name. Okay. 176 point. Okay. Yeah, that is good. That is correct, in fact.
I also did it.
Okay, what is the value?
The frictional force.
Yeah, the frictional force.
172.8.
No, it's supposed to be 176.4 Newton.
Oh.
Getting it? Like here, the coefficient is given how much? It's 0.45. No? Yeah, it's 0.45 here. So based on that, the answer coming will be 176.4. Okay, see if the calculation you have done correct or not. So basically the given things, the question was mass was given as 40 kg, right? Coefficient of friction.
We have done wrong in multiplication.
Yeah, so you have to improve on that. Okay. All right then. Now let's come to the NCERT exercises then. All right. Okay.
Yeah. Yes, sir.
Let's see if the questions are visible properly or not. Huh? Can you guys see the question?
Sir, it is. Yes, it is.
If not, you guys can take out your
visible.
notes. Okay, now see question number 1. So question number 1 is classify the changes involved in the following process as physical or chemical changes. Right. So photosynthesis, that is an example of
Chemical.
Okay. Guys, we have done. Look. That's a different slide I have taken here. Okay, that's not related to the chapter. Okay. You guys can do one thing. You guys can take your books out. Okay. And let me open the PDF of the chapter. All right.
Yes.
So in this manner, we can discuss it. So let me get the PDF of the chapter. All right.
Hmm. Yeah, I've taken off.
You're done. Okay. Now the first question says that
Wait,
friction opposes dash between the surfaces in contact with each other. What does it opposes? Yeah.
I'm sorry, can you repeat again? I don't
suppose force,
that.
support.
You guys have opened the same PDF, no? Or same chapter, no? Friction. Let me say the first question. Let me see if I've got the correct PDF or not. The first question is friction opposes the correct, no? Okay. Friction opposes not only the force. The more appropriate answer is that it opposes the relative motion. Right now, force is being applied by us now. We are the external agent who applies the force on it. In fact, frictional is also an external force acting on the object.
Sir,
But
I
it
don't
opposes.
have this question.
You don't have the question.
In my book.
This question.
No.
We read the first question of NCERT exercise.
It's what is friction?
You don't have fill in the blanks in your book.
I have. It starts with rolling friction is dash, then sliding friction.
Okay. While Arhan, you have got different book. Okay. So you guys now are having.
I've got the friction opposes the dash between surface and contact.
Okay. I guess one of you have got the old edition of the NCERT. Right. Okay. So Arham, do one thing. Just check for the edition. Is it the latest edition?
Yeah. Let me check.
Okay. Check the year of the edition. Okay. Well, I think Arhan, you have got the right PDF, the latest edition.
Yes, sir.
Okay. While you are checking, we can keep on discussing the questions. Right.
Yeah.
Okay. Now, friction will depend on dash of surfaces.
The rough surfaces.
Basically, smoothness of the surface, whether it's rough or irregular.
Smooth.
Friction produces dash.
The heat.
Heat. Right.
So this is the 2021-2022 book printed on 2021 and 2022.
Printed on 2021. Okay.
Yeah.
So that is, I think, the latest edition you are having. Okay, let me open the PDF. Just let me get the PDF. No, all the PDFs which I'm getting here, all of them starts with the question friction opposes the dash between the surface in contact with each other. Okay. Look what we will do now. Just give me a moment, guys. Okay.
Yes.
Okay, sir.
Okay. Let me open the PDF on my phone. On the device I'm connecting here. Okay, can you guys see my screen?
Yes, sir.
Yes.
Now better. No, see the question here. It's the same question. And in fact, this is not the latest one, I guess. Okay, guys. Okay, so see the first question. We have discussed these questions. Question number D, sprinkling of powder on the carom board, that will reduce the friction.
Yes.
Right. Okay. Next question. Lubricants reduce friction between surfaces. Oh no. Next question. What does it say here?
The sliding friction is dash than the static friction.
That is more or less?
Lesser.
Lesser. Right. Okay. Then for children, 4 children were asked to arrange forces due to rolling, static, and sliding friction in decreasing order. Okay, let's arrange them. What is the correct order, guys? Out of 4, which one is correct? C, no?
Yes, C.
Maximum to minimum, static, sliding, then rolling. Okay. Okay, Alida here runs her toy car on marble floor, dry marble floor, right? And newspaper and towel is spread on the floor. Wet marble floor, newspaper and towel is spread on the floor. The force of friction acting on the car on different surface in increasing order, right? So the force of friction will be maximum in which one? Obviously in the wet marble of floor now. Then it will be less in dry marble floor, then newspaper, and then towel, because the surface of towel is smooth here, right? Okay. Suppose your writing desk is titled is tilted a little here, right? So if it is tilted a little, a book kept on it starts sliding down. Okay. So we need to show what direction here, no? Direction of frictional force acting on it, right? So suppose the book is flowing downward like this, right? The book is flowing downward like this. The force of friction will be upwards towards it. Can you guys see see this here?
Yes.
Yeah, it is coming down because we know friction always acts in a direction opposite to the applied force or the motion of the body, right? You spill a bucket of soapy water on marble floor accidentally. Would it make it easier or difficult for you to walk on the floor?
Difficult.
Difficult.
Because
it
reduces the friction.
Yeah. And while walking, when our feet pushes the ground backward, the floor pushes us in the forward direction. And here friction plays the most important role in this process. So when you spill a bucket of soapy water on a marble floor, friction between our feet and the floor decreases, and the force responsible for pushing you in forward, that becomes weaker. Therefore, it becomes more difficult to walk for us to walk on that floor. Okay.
Yes.
Explain next question. Yeah, question number 6. Yeah, sure.
The sportsmen use spikes since it increases their friction, and spikes give them better grip so they do not slip while running.
Also, you can add one more point that
flowing friction.
One more thing can be added here. No, spikes increases the interlocking effect. Interlocking of the surfaces is increased here, right? That increases the friction and gives them a better grip. Okay. In fact, even if you try to walk using this shoe, that gives a better grip. Okay. So do you guys participate? Okay, very good. So you guys participate in the sports, no? In school?
Yes.
Okay. What are your favorite sports?
Football.
Football, both of you. Okay. Me also. I also like football. In fact, I like football more than cricket. Okay.
Yeah.
Question number 7 here. Iqbal has to push a lighter box and Seema has to push a similar heavier box on the same floor. Who will have to apply a larger force and why?
Seema, because she's pushing a heavier box. Then the applied force is more.
Exactly, because a heavier object has got more mass, it will be experiencing more friction, right? Because the surfaces are being pressed more harder, right? So if the surfaces are being pressed more harder, look here. Here. Surfaces are being pressed more harder. So if the surfaces are being pressed more harder, that will also increase the interlocking effect now. Isn't it?
Yes.
Okay, so that is also the reason. Okay, explain why sliding friction is less than a static friction. Why sliding friction is less? Yeah.
So, it is less since the interlocking of irregularities in two surfaces is higher when the object is moving.
Look here. When the irregularities between two contact surfaces get interlocked, it results in resistance, which we call as friction. While in the case of sliding friction, the time for which the surfaces are in contact is very small. Like the objects are continuously moving. So they don't get enough time. Yeah.
That in sliding friction the object is moving, so there is interlocking. But in static friction the object is not moving because it is not experiencing that much of interlocking between the hills and valleys.
Exactly. That is the reason. Now, like for a fraction, they get only a fraction of time, so they don't have enough time to build up the interlocking effect, right?
Yes.
So although they get they are having a grip over each other, but that grip is being broken since they are under motion, right? So that is the reason why sliding friction is less than the static friction. Okay, now give examples to show that friction is both a friend and a foe. Okay, so one of you, Arham, explained how friction is acting as a friend.
Friction helps us when we are sitting. Friction helps us
Walking,
to
running,
produce heat. Yeah,
to
it
produce heat.
produces heat, which is used in many things.
Hmm.
And without friction, you can't go think everything just slide over.
Mm-hmm. We're able to write with a pen or pencil due to friction.
Due to friction.
Okay. Then Arhan, you list some of the demerits, how it acts as evil.
There are shoes tear due to friction.
Yeah.
When tire declares, it is difficult to move the cast because the increased friction and the road surface.
And friction also leads to loss of energy as heat now, right?
Yes,
Energy is lost in the form of heat. Then because of friction, as you mentioned, the tires and soles also wears out. Okay. Now explain why objects moving in fluids must have a special shapes. I think that's the last question, no? Yeah, that's the last question. Why they should be having a special shapes?
And they should have a special or slimline shape to cut through the air and friction.
Look here. Especially in the case of fluid friction, the fluid friction, we know it depends on a number of factors. Like it depends on the nature of the fluid, shape of the object, right? These were the surface of the body. These were the things which determines the fluid friction. Okay, so several things can be done. So for here, an object has to be moved in that fluid. So we have to make changes in that object only, not in the fluid, right? So whatever nature of the fluid is given there, right? We need to make modifications in the body. So what can be done? We can simply reduce the contact surface area of the front portion, right?
Yes.
Overall contact surface, that cannot be minimized. That will remain same. You have got a piece of a square. You can make it into a piece. You can give it a streamlined shape. Okay, but the surface area will remain same. So what if we are to make the front area, which is in motion, which is in direct contact, okay, with the fluid molecules. So if you were to reduce that, that will also reduce the frictional generated there, right?
Yes.
So these are the things here. Okay, so basically the chapter has been completed here, right? Any confusions from the chapter?
Yes, sir.
Yeah, which one?
Sir, how do forest fire take place?
Yeah. That's a good question. Look, basically, what happens now? Draft, you guys know that's a prolonged condition where there's a no rainfall, right? Okay. So obviously, due to no rainfall, plants will start to die, right? So in the basically, you will see deciduous forest, deciduous plants, right? That sheds their leaves. Okay, they don't receive too much of rainfall, or usually in the grasslands, right? So due to climatic factors, if the usual pattern of rainfall is disturbed, right? For example, here, especially in India, the monsoon rainfalls which you see, the monsoon rainfalls, it is due to western disturbances now. The
Yes.
moisture laden winds that comes from the Arabian Sea.
Yeah.
This is your India
Yes,
here. This is your Arabian Sea, right?
Hmm.
This is your Bay of Bengal. Okay. So moisture
Hmm.
laden winds come from the Arabian Sea, and it leads to most of the rainfall in the northern parts of India, right?
Yes.
So let's say what happens if let's say what if there's let's say the Arabian Sea dries here, getting it?
Hmm.
So if it dries, will there be rainfall in the northern part of India?
No.
no, sir.
Obviously no, right?
Hmm.
So there will be prolonged condition in which there is no rainfall. Obviously the plants are going to die. Okay, so
Yes.
they die basically. It means that the moisture content in them is also lost after they are
Hmm.
dead. The moisture content has evaporated. There's no moisture, no vegetation in the region. So ultimately, it has got
Yes.
dry here, right? And there will be flow of wind in there as well, because we know wind will flow from higher pressure region to lower pressure region, right?
Yes.
So we
Hmm.
know in a desert, or let's say a region where there is no rainfall. So no rainfall means what? No moisture, right? And why there is no moisture? Because also there is sunlight there. I mean to say that there's more insolation, more amount of sunlight is falling on the region for maximum part of the year. Getting it? So all these factors leads to dryness in that region, and also you one phenomena which I was explaining here, that there's mm, how hot winds flow into that region, warm winds, how it flows into
Yes.
that region, because that has
Hmm.
a special role to play in the forest fire. So
Yeah.
basically, there's a low pressure created here, low pressure region. We know that
Hmm.
warm air tends to rise above, right? So
Yeah.
also the
Hmm.
air molecules present in a dry region will tend to rise up, and surrounding air will rush to take the place here. Getting it? Okay.
Yes. Hmm.
But where do the surrounding airs will come from? Like the surrounding airs that will be coming here, that will also be drier. Because, for
Hmm.
example, let's say if the Arabian Sea has gotten dry here, okay, so the moisture
Hmm.
laden winds won't be coming in this case. Okay, so all this
Yes.
leads, basically, I'm trying to conclude here that basically there's a dryness in this region. The plants are very dry. So when these hot, warm winds will flow across the plants, the branches of the plants will rub across each other, and due to high temperature in that region, the plants will basically autonomously catch fire.
Fire.
So that is
Yeah.
how forest fires take place.
Hmm.
Okay.
Yes,
Okay.
sir.
So,
Yes.
the reasons it is for desertification. Okay. Desertification is a condition where there's no rainfall for a
Yes, sir.
prolonged period of time.
Yeah.
Getting it? So these all leads to
Hmm.
drying of the plants. Warm winds. Okay. All right then,
Hmm.
guys. Okay, so that's it for today. We have completed the chapter. Okay, in the next class,
Yes.
we will begin with the new chapter then. Right?
Okay.
Yes, sir.
Okay then. Okay. And have you
Yes, sir.
guys been preparing for your test now? You guys prepare for your next test.
Okay.
So when
Oh,
is your next test?
okay. You guys will be updated regarding the test. Right.
Okay, yeah.
Okay,
So
but
it will be of science, right?
keep your preparation keep your preparation ongoing. Okay.
Yeah.
So it will be of science, right?
In the previous class, in the previous test, we had of maths, right?
No, sir, science.
Science. So then it will be supposedly of maths then.
Okay, sir.
Okay.
Okay, okay. But prepare for both the subjects. Keep revising
Yeah.
both the subjects. All right.
Okay, sir.
Yes.
Okay then, guys. Allah Hafiz.